Alright, in this video I'm going to talk to you about the function transformation vertical stretch. Now, if you're looking at an equation, you're going to know that there's going to be a vertical stretch if you have multiplication being done on the outside of your function. So the function is performed, so in this case the x is being raised to the third power, and then we're multiplying it by 2. Okay, so that's important. We're multiplying the outside. That's what's going to cause a vertical stretch. Now, in order for it to stretch vertically and not compress, we have to multiply by a number greater than 1. Okay, and you're going to see why here in just a second. So if you're looking at a graph, a vertical stretch is going to make the graph skinnier and it's going to make it longer. Okay, and that's what it looks like. Now, if we're talking specifically about how do we perform this transformation, let's take a look about how our different points change. So for y equals x to the third, you know that there's a point at 1, 1. So we have an x value of 1 and a y value of 1. For a vertical stretch, we're multiplying all of our all of our y values by the number that is on the outside of our function, or being multiplied on the outside. So in this case, our y value is 1. 1 times 2 gives us a new y value of 2. You see how that stretched our graph out. If we multiply it by 3, that's going to give us a y value of 3 because we're multiplying our y values by 3. Okay. Now, the same thing goes on the negative side. If you're looking at this, so for the negative, we have a y value of negative 1 on the parent function. For the y equals 2x to the third, we multiply that y value by 2. Negative 1 times 2 is negative 2. That's our new y value. And then negative 1 times 3, that's our new y value for y equals 3x to the third. So notice, our x values do not change when we're doing a vertical stretch. The only thing that changes is the y values. How do they change? We multiply them by the number that is on the outside of the function.